So any doubts regarding the certification or how to complete the certification or LP, we can discuss once the speaker is done with the session. So don't text anything regarding the learning plan or how to do the certifications. So if you have any such doubts regarding the certification, we'll be discussing in the end of the session. Okay, we'll be starting in another 2 minutes. So please ask your friends if anyone is missing or anyone didn't join. Uh, please ask them to join. We'll be starting exactly in 2 minutes. Yeah. So I think we can start the session. So yeah, I think we can start the session. So we are, it is 4:06 now. So I think we can start the session. So if there is anything if there is anyone ready to join, please ask them to join. If the meeting is exceeded 900 plus or 1,000, so we can they can join on YouTube. So yeah. So a very good evening, everyone. I will everyone please stop texting. I request team members to switch off the chat box. Yeah. Welcome to Masterclass 2 of the IBM SkillsBuild PBL program. Applied artificial intelligence, learn, build, and create. So today's session will focus on the industry relevant tools and practices, which will help you to understand how AI solutions are built and deployed in real time industries or the environment. So it's my pleasure to introduce Mr. Shashank, principal scientist at IBM, with over 10 plus years of experience in data science and analytics. He had led expertise in AI solutions across the industries using tools like Python, NLP, Watson, cloud platforms, and more. So, without further delay, I invite Mr. Shank to take over the session. Over to you, sir.
Thank you, Sai, for the introduction. Good evening, all. Let me start sharing my end of the. Hope you are also able to see what I am able to showcase. The link would also be given to you. It is basically github.com slash data hyphen prep hyphen kit. That will take you to the organization, which is and the repo within it is again with the same name, data prep kit. So the link would have been like this. I mean, if you click on, if I just type so when you enter, this is where you will be entering. And once you can browse all the other links later, but either you can go through the repository link, or since there's only one repository, you can directly click it here as well. So the information about this project is available in the data prep kit at github.io. So that takes you to this link. So if you have any trouble anywhere, I mean, specifically you want to reach out, this is a step of guidelines that you can go through at your own convenience, and do the steps that are listed over here. So for this project, what you would be doing is using Google Colab. So I'm assuming you already have the Colab access and everything. So you can first download the data prep kit by, if you have Python already installed from the previous session, which Divya has done a couple of days ago. You can directly do pip install and data prep kit toolkit transforms all. So we will switch back and forth. And if you are a Windows user, Windows and not Linux or Mac OS, there might be additional steps which you might want to find out, which you will be able to uh, go through. I mean, like, what are the packages that are required, like PDF to Parquet, doc chunk, doc quality, HTML to Parquet, personal identifiable information redactor, text encoder, document identifier, edit up, filter, HAP, profiler, resize, and tokenization. Uh, so, I mean, the working environment used Python 3.12.7. So the Python versions might be interchanged. If you have 3.10 or 3.11 or 3.12, you can use one of them which you have installed on your particular machine. So I'll just go through a little bit of context here. I mean, while I'm talking through, you can also go ahead and do the installation of it. You can even fork this repository as well. So the data prep kit actually accelerates. I mean, in the industry, we don't recommend writing everything from scratch. We recommend, when you're working on projects, to do accelerators. So this data prep kit is an accelerator which helps in accelerating the unstructured data preparation for LLM app developers. And the developers can use data prep kit to cleanse, transform, and enrich use case specific unstructured data. I mean, the key highlight is use case specific unstructured data. To pre-train or fine-tune LLMs and instruct tune LLMs, or to build RAG pipelines, uh, or in this case we will be doing a AI agent using it. I mean, we'll be taking two examples. One is code, and the other is a basic transformation based on natural language processing. So the features of the toolkit is it has a growing set of modules and transforms. Uh, so it can target either be done on your local computer in your lab or on your laptop, or if a big data center is there, it can also handle that scenarios. Currently, it is supporting natural language. It also supports code and images. We'll be talking about the first use case would be code, and the second would be for natural language, which we'll be taking up. And the modules are built on common frameworks. We'll be doing Python because that is the intent of this session. There are other runtimes as well, like Ray and others, which you can dwell into if you want at a later point in time. And we also have a framework for developing custom transformations, which are not coming out of the box for your specific use cases. These include for processing Parquet files, zip files, JSON in ND format and line format, uh, and the it can also be deployed on Kubernetes clusters. We will not be touching that part. We will be in the subsequent class talking about relay. So that is where you will be talking about that part. The deployment of AI agents will be not be done in this particular thing. Uh, so we have already covered this. I mean, some of these things which you might have already done with Divya on Wednesday. If not, you have tutorials as well. So whatever you want to do, I mean, if you want to go back and do the basic ones, you can also go through the recipes that are already uh, created for such use cases. Uh, and if you want to develop your own transformation, you have a developer tutorial of guiding you how to do it for your own use case. And if you are far more advanced user, if you want to go to the next level, there's more information on how to running the transformations from the command line, scaling and automation, and everything is discussed. We will touch it at the last if you guys need any more information in this regard. I'll just keep it open so that we'll go and touch it at the end. And the data files are available in Hugging Face. So you can use them in testing. It can be referred here. I'll also open this and keep it open. I mean, all the modules can be directly accessed from the links that are given here. And they are combined to form data processing pipelines as shown in the examples. So the examples I'll be showing you is specific to Agentic AI. Some of them would be using Dockling, some of them would be using PDF to Parquet. So depending on the use case, it would be different types of data ingestion. Then we have universal, both code and language common specific transformations. Then we have language only transformations and code only transformations. And finally, we have three specific to images. After that, we also, if you want to contribute to new modules, you can do that. For more information, you can reach out to this link. I'll showcase that to you as well. And the information that is done here is part of research papers, talks and presentations and tutorials are also made available. The Granite open source models are hosted on Hugging Face, and Ignis is the actual on which the data prep kit is based on. That is an IBM research initiative. So all that information is available from the resources part of it. So this is a very basic understanding of what is data prep happening doing. We'll go through the subsequent links now. So if you are an advanced user, you can build your own transformation. So what you have here is different pathways that are there. One is from HTML to Parquet, PDF to Parquet, or code to Parquet. And this is used for code quality and semantic ordering of the repository. So they'll be using programming language selection. They'll be using the filtering transform and PII detection. So if you are just generally passing through HTML or PDF documents, we first do the deduplication so that you don't waste your tokens or cost when you are time as well when running the LLM calls. Then you try to think of the document quality, then the tokenization. Once the tokenization is done, you will be thinking of document chunking, and finally the embeddings. The embeddings are then stored in a vector database, either in memory as well, or something which is available like Milvus and other. So Milvus Lite is the memory equivalent of it. Uh, then you can use that information for fine tuning or retrieval augmented generation or instruct tuning. Uh, so I mean, you can the context of it for the advanced is given here. How to do the scaling as well is given, and how to use the Hugging Face data. Uh, and the repo structure is also given. You can use either Docker or Podman. At IBM, we recommend Podman instead of Docker to continue your activities. I mean, it's the same. Instead of a Docker, you will use Podman as the command and take it forward. So there are data processing libraries. Then the data processing library is available in Python, Ray, and Spark. So you have these three runtimes which are made available. Then we have the transforms, which we have talked about. We have showcased the universal transformations, which are common between code and language. And then we have code specific and language specific transformations. Then we have the Kubernetes deployment support, which we will not be covering here, but I just the structure of that repo is like that. Then we have scripts which contain the build and make files. And this is primarily for administrators to perform Git management, Git actions and release management, and for developers to work with the core libraries and transformations. You have the basic Git commands as well, how to clone the repo, how to move into the data prep kit and then start checkout and add a remote branch so that you can fork your own URL, and you can then start to build and run it at your local. It would require some amount of, especially for LLMs, you need access to one of the API keys for which you have. So it will support multiple of them. I'll come to it a little while later. Okay. Let me switch. I think this is also done, right? Yeah. Okay. Okay, this is for contributing back. If you have found any bugs or you have come up with a transform which is unique. I mean, I think Divya also spoke about it. So your contributions mean a lot to building your own profile or resume. So if you are contributing back, people will regard you very highly. So this is the process you have to follow to ensure that you are contributing or creating issues when you find some issue, or how if you are fixing a bug, or if you are doing any of these work. This is how you need to take it forward. Okay. Yep. The final resources, I mean, this is the research papers I was talking about. There are three papers that have been published from this particular project. You also have example code and a set of tutorials. This you can go through, and there are also online communities available. So what happens here is, if you need any help, you can go to this data prep kit Discord channel, and there will be communities of peers who would have already faced this issue, and somebody might have advised them how to go about or resolve it. you can first go through what is already posted there, and if you find it is not addressing it, you can create your own specific uh, item saying that I followed this. If you want to raise a new ticket or something of that sort, saying that I've done these steps and this is what the result is, and you can ask for help. So this has been used data prep kit in multiple external events. A long list of them across the world. So you can also refer to those information as well at a later point in time. Okay, let me close this. Then we have, this is where the IBM Granite models are hosted. Hugging Face, from which if you have the API key, you would be able to make a poll, send your input. It will process it and send the output based on the prompt that you have defined. Okay. And this is Genesis web dataset. It's a long one. I would not go through it now, but you can go through it at your own convenience at a later point in time. Okay. So we are back to the start. The quick start we have already covered as well. So we are going to the agentic part of it. So if you go to, if it is the same thing, like examples and agentic. If you click on it, it is coming to the same page that I have opened here. So what we have here, like I told, there are two use cases. One is for code generation. The other is for LLM transformation based on what is the natural language input you have given. So we'll be taking both these together. And we need to have Python 3.11 installed. This is what is recommended. At the time this was written, it was 3.11. At the time the major repository was created, it was 3.10. So people might not have updated it. So if you are installing and it is 3.12 or 13 or 14, it is fine. Or if you know how to enforce it to have this particular version, you can go ahead with that as well. Okay. And we have talked about how to clone the repository. If you have not already done it, I would recommend you to take a minute and clone the GitHub repository and switch the directory using the command cd to examples and agentic. And you might also have known that the best practice is to create a virtual environment. So your global environment doesn't get affected when you're installing the libraries or the requirements, whatever the libraries from the requirements.txt file. So from that perspective, these are the set of commands to execute it within Python to first create the virtual environment. Uh, uh, you can name it different. Here in this example, it is given the same name, VENV, but you can name it data prep kit virtual environment or whatever date or some combination. Then you have to activate it using the command source, whatever is the name you have given, which is common to here, and bin and activate. So once it is done, you do a pip install to install upgrade pip, install Jupyter, IPython, and IPyKernel. So once these requirements are already done, you can then install the requirements.txt. So this will take a bit of time. Let it run in the background. I will go through the subsequent steps so that you would be able to comfortably understand the code, what it is doing when you're running it, and how to move forward. So, like I have spoken earlier in the session, we need access to LLM. You can either have replicate Watson X on IBM, or you can download the open source Olama, Llama CPP or any other equivalent of it on your local laptop. IBM, the team who has hosted this repository, has done the testing on Mac, but it can be Windows or Linux, whichever machine you have access to. So if you do not have API keys for Replicate or Watson, you can use the Olama option as well. So the notebook cell that defines models contains all frameworks with only the replicate part uncommented. So to use one of the other frameworks, uncomment its part in the cell while commenting out the other frameworks. So by default, it is, you know how to comment, right? You put a hash before replicate and remove the hash before Watson X or Olama, depending on which one you are taking forward. Please note that the frameworks have been tested with a specific LLM, and due to inherent nature of LLMs, using a different model may not produce the same results. Or what happens is, depending on the parameters you specify, it will be similar, but not the exact output would be visible to you. So there would be some variations in the output, but the process would be taken care of from that perspective. So if you are having an access to a replicate API token, you can use it in the .env file in your project directory. If not, you can download Olama using olama.com/download and download one of the supported models. I mean, there are a lot of models available which are supported in Olama. IBM has tested with Llama 3.3 model, so we recommend you use this one. I mean, it doesn't matter which one, but at the time this file was written, it was this. So if you are using a different Llama model, you can change that version. If it is saying model Olama 3.3, you can change it to whatever version you have downloaded. If you have access to the IBM Watson X, you can obtain its API key, and you can gather that entry point. Watson X entry point by default is this within the US South region. It can be somewhere across the world, depending on which location you have signed up for. It can be in Asia Pacific or Europe, wherever the access is available. Then you might have created your Watson X project in that instance in the web URL. That ID is what needs to be replicated, not the name, just the ID of it, which is a GUID. Then you will have a API key, which also is protected, which is needed to be able to access or authenticate your self to this URL against this project. Okay. Going next, you just launched the notebooks using Jupyter Notebook. I'll quickly close these two. So the first one which we have, so if you come back here, this is the one. If we click on this, it will show the same one which is here, which is the data prep planning kit. This is the code accelerator which I was talking about. So the code accelerator has basically 4 steps. It has a planner phase, and it has a judge, and it has a code generator and a code validator. So it does all the tasks within itself. So what are the components that are used for the data prep kit transformation? The tools that are used are PDF to Parquet, doc quality, EditUp, doc ID, lang ID, and filter. The planner parses the task description, identifies appropriate transforms, determines the correct order of the transformation, creates a JSON formatted plan with the required parameters. Okay. And the judge properly addresses the task requirements, follows all the specified constraints, does not include any unnecessary steps. Inputs for each transform are specified. It judges the what is the output of the planner based on this, and then the code generator imports the necessary Python modules, set up the command line arguments for configuration, implements the workflow with proper error message handling, and manages the flow between the transforms. So we will go a little bit in detail in these steps. I mean, the requirements is specified in the requirements.txt, and the requirements for the other use case are specified in the dpk requirements.txt. So I'll go through the requirements. It will basically contain the list of libraries which I've spoken about a little earlier. With respect to the code part of it, the task processes the provided PDF dataset to identify and extract only documents that don't contain inappropriate language. So it is after installing the requirements from IPython, it is importing HTML. It is also importing the logging function and access to the local OS environment variables. So whatever you are storing in .env will be able to access from the OS thing. So we also import various utilities which are present in the path LLM utilities. If you go here, and under that we have the DPK and tools. So all the utilities that are there are specified here. And the next is to import the example task. I mean, so that information is also imported from examples. And once that is done, it is printed out. So all the constraints that are used, that are mentioned, are also taken care of, and it is specified and taken those whatever the constraints that we need to add, we can add it in the constraints.python file. So from that perspective, we can tune it as per the requirements. I mean, again, this is a replication repeat of what we have discussed. You can either use replicate, Olama, or Watson X. So depending on which one you choose, you can comment out the part which you want to. So you remove the hash before either Watson X. This is replicate, and this is the Olama. No, sorry about that. This is not replicate. Replicate is already here at the bottom. Yeah. So this entire thing is for Watson X, where you have the LLM plan, LLM judge, and LLM generate. You directly use that for Olama, and then once we have access to replicate, we can use this here. Okay. And we are using LangGraph in this particular case. So LangGraph, we import state graph and the end from langgraph.graph. We also have agent helpers, planner prompt, judge prompt, generate prompt. We'll go in detail of these prompts a little below after this. And from the data prep kit, we'll use the tools. All the transforms that are there are created, imported as tools. There are also some examples and constraints which we have talked about above. And from function tools, we are importing partial. Okay. So we are first creating the graph using the command state graph state, and we are adding nodes. So this is the way once you run, you will have a planner at the start. You will have a judge. Then you will also have a user review where you can give yes or no or response to what is decided by the planner, and how the code judge determines whether it is good or not. Once these two steps are done in concurrence with the user review, we go to the code generator, which generates the code, and then the code validator, which would be validating the code that was generated. So once the nodes are added, we'll add the edges as well. So we are setting the entry point. The entry point is planner. Then we add the edge from generator to validator is one edge, and validator to end is the other edge. So we then add the conditional edges. The conditional edges is a judge based on if it is the is plan okay is a check. If it is true, it goes to user review. If it is false, it goes back to the planner. And another path is for the judge. It has a checkbox or addition for need judge, where if it is true, it goes to user review. If it is false, it directly if it's true, it goes to judge, and if it is false, it goes to the user review. And we also have another conditional edge for user review. If the user review is okay, it goes to code generator. If it is not, it goes back to the planner. Let me try and share one more. Okay. So this is what I wanted to show. So when you run it, it will create something of this. So the start is defined here. Then the planner. From the planner, it if judge is required, it comes here. If judge is not required, it goes to user review. From the judge, if the output is good, it goes to user review. If it is not good, it goes back to the planner. Okay. And from the user review, if user says I am also fine with it, what is generated by the planner and the judge, it goes to code generator. If it is the user is not happy with it, it goes back to the planner. So these are the conditional edges which we have created. The standard edges are from start to planner, code generator to code validator, and code validator to the end. Okay, let me share. Yeah. Okay, so we are back to the code. And now we are importing requests to make HTTP calls to the workflow. So we create an app where workflow is compiled, and we are so when we use the mermaid syntax, whatever I have shown to you would be created. So that response is retrieved, and you can see when the output of this is basically the diagram which I have shown to you. Okay. Then you can run the graph using the commands that are here. So let me take you through the prompts as well. So LLM utils. Okay. So we have the planner, judge, and generate prompt. The judge, planner, and generate prompt. So we'll start with the planner prompt. So this is how the planner prompt is looking like. Uh, and if you see what are all the tools that are specified are restricted. We only are giving access to a finite set of tools which are defined in the tools. The constraints are given as context. The examples are given as an example task. And what was the previously generated plan? If this is the first time you are generating, this would be blank. But if you have generated a previous plan, that would be part of the memory, and that would be used here. And the feedback from the previously generated plan, either the judge feedback or from the user feedback. So that information is also stored here. And what is the updated plan based on the review that is done here. So this is how the planner prompt is given inputs, and the final plan is outputted. So the prompt is defined. I mean, you will have a set of statements. Most of the statements are relevant, like not to add any superfluous steps. And the result of the final step should be the final answer. So these are things which are like guidance. So if we don't give a goal to the agent, what will happen is LLM is kind of aware of all the information that it has access to. I mean, if I've gone through the Genesis web IBM research page, you will see it has some access to somewhere around 10 trillion tokens. So it would give information which is probably not of relevance to you. So we want to ensure that it is hardened to look. I mean, like a horse when it is running, you want it to only look in its path and not bother about whether other horse is running beside it or not. So you will use a blinder or a blinker to showcase it, to see, to enable it to see only ahead and not to the side. So the same way we define the prompts, we guide with the series of steps that are given. So we are saying, in this context, the context is you are an expert in planning data access. For the given context, create a data pipeline to accomplish the given task. The task is again defined, and this should involve individual tasks that, if executed correctly, will yield the correct answer. So all the information, how it is given, all of that is given here. And the same, the output of the planning, if the decision is required for judge, will go to the judge prompt. So in the judge, you have the evaluation parameters in terms of what is the task, the tools, the constraints is given in the context, and the actual plan that was generated by the planner prompt. So that comes as input here, and the assessment of the plan's validity is done. And if any issues are found with the constraints or the context that is mentioned, it is specified in no more than 3 sentences. I mean, if you do not give a specific instruction like this, like no more than 3 sentences, sometimes it keeps on going on and on. So you might want to restrict that to what is relevant, and show what are the unnecessary transforms so they can be removed. And on a different line, right, either this needs revision or the plan doesn't need, that was generated by the planner prompt doesn't need revision. If it doesn't need revision, it goes to the user review. And then we have the generate prompt. So after the user also reviews the output, it then goes to the actual generation of the code, where the data prep kit is generating code for transformation of the data from data ingestion to language transformation or code transformation or both, or image, and what is done here. So the assumption, again, the key requirements are specified. The input is basically the each step in the plan is mentioned here. The plan is coming here as the input. That all the tools are available in tools.python file, and we just need to import them. And we need not elaborate the implementation of the tool. So what are functions you are writing is specific to the business logic, not to replicate the code that is already available in the library. We need to start with a main function, which will be accepting variable number of parameters as command line arguments using argument parser. And we also create an execute workflow function that implements the plan step by step. Each step should show its result in a results dictionary using the step evaluation as key. Each subsequent step should be able to reference the previous step results using the step evaluation values. Any basic error handling and logging of the processes also need to be done. The script should be able to runnable from command line. So you can run it like Python and the name of the file that is generated. The Python code should include the dictionaries of the plan steps that is taken care automatically as defined above. Pass the plan steps for each step and add its tool call. There should not be any hard-coded values. It has to be removed and with default values of the argument. Okay. And let's go back to the code. So the requirements.txt, basically this is an implementation which was done in LangChain. So the versions that are mentioned here are probably a little older. You might access the later versions of it. But here it is LangChain version 0.3.1, IBM Generative AI 3, LangChain Olama 0.2, LangChain IBM 0.2.1. And if you are using OpenAI, it is 0.2.14. And LangGraph, for the state graphs which we have seen, it is basically 2.35, 0.2.35. And if we are making calls using the IBM Watson X implementation, you need the IBM Watson X 1.1.11. Then the .env, to access the OS related information, the .env package, what are variables we have defined there. Py to PDF to be able to parse PDF files. Replicate if you are accessing the replicate credentials. And black is for formatting or linting. There's also a transitive dependency. You might want to downgrade and restore it. So all the information that you require, and request is the main package to be able to make the requests to generate the plan which is visible to you. So do you want to take a break before I move to the second use case, or should I continue?
So we can continue with this.
Okay, I'll move on to the next one. I'll close the first use case. So what we have here is the data prep kit. This can be implemented either in LangChain or in Llama Index. So you now have two options in the advanced stage. So this contains basically PDF to Parquet extraction for extraction of text from PDF files. So once the text is extracted, we then chunk it into multiple to set the context properly. So you would have something like A, B from the first file, and uh, A A implements or A1, B and C, where B and C are common between both the texts, whereas A and A1 are different and C is additional. So from a document perspective, you will see you first use the document ID generator to generate unique documents for all these. And we do the dedupe of it. Wherever there are some exact things, we just remove the duplicates. So once that is done, we also do a fuzzy dedupe where it sees that A and A1 are almost similar and is a near duplicate. So it is removing the one of that instance. And only after this is done, we then make an embedding call to generate the embeddings and store it for further use. So again, the requirements in addition to the requirements which you might have run earlier, we also have the dpk requirements.txt. You can also go ahead and run this. This will take some time. And we also go to the Llama Index tools and install the same specific to the Llama Index tools as well. And we install Llama Index. Okay. We can use either LangChain, which we have used earlier, or Llama Index, depending on which you are comfortable or you want to try something new, you can do this as well. Okay. So by default in this code, it is defined as LangChain is false. LangChain you have already done in the first use case. So by default, it is a Llama Index. But if you want to continue using that, you can skip these first top two steps to install Llama Index. Then you can set this to true and run this command and go forward. We are also not using local array. We are using Python. But if you have if you are comfortable and you all have an access to an array cluster, you can set it to true. Okay. And then we have to set the input and output paths. So we again, whatever is your current working directory, from that we have created output folder. And then we also have the input folder, which is the test data and input. And output folder is whatever the base path which we have created and the final version one. So if you are making multiple changes and trying to compare the outputs, like experimenting with it, so you might want to change this number to a different number so that it doesn't overwrite, and you would be able to compare and see what are the effects of what changes you have made in the code on the outputs that are generated by the code. And if you don't want to do it and you want to discard the output which was generated earlier, it will basically clear that existing directory, and what are newly generated outputs would be stored directly in this particular case. Okay. Then we will be setting the transformation parameters. So we would be preparing the parameters which come in the form of a dictionary, and we join them with and by removing the curly braces and send it back in the form of a dictionary. Okay. So the PDF to Parquet parameters are basically data files to use. And what is the file name? I mean, so it will only select everything which is ending with a .pdf. And the input folder is given. The Parquet contents type is applications JSON. That is the input type. And the output parameters, once we run that command, will be coming and stored in this particular dictionary. So there are doc identifying parameters like doc ID hash column, which contains the chunk hash, and doc ID integer column, which also contains the chunk ID. This is the number, whereas this is the hash. The hash is generated based on the content that is there. For the deduplication, we use the hash. We don't go through the entire content. We only use the hash, which is generated on behalf of the content that is there in the chunk. And this is the dedupe column. So this contains the contents and the chunk hash. So then we have the encoder. We pass what is the encoder model. In this case, it is a transformers model, the sentence transformers, which is hosted on Hugging Face. It is a mini LM uh, and version 2 of it. And the output is stored when the text encoder output is stored in the output folder. So it will be a vector representation of all the text content that you are seeing. So we are not running with local array, so we are ignoring this part. So we are passing the dictionaries to the prepare params, and the output of it is stored in the respective variables. Once the parameters are done, we are just saying for PDF Parquet what parameters, for doc ID parameters, deduplication parameters, and text encoding parameters, what we are using, and all those parameters and the task that is there. So in this case, there are different tasks that are defined here. There's a print, the PDF to Parquet, doc chunks, doc ID parameters, deduplication, and text encoder. So all these tasks are created. We can, again, like we have defined earlier, we use either replicate or llama or watsonx, depending on which environment you have access to. And once we have done all the setup we have done, we would load the from .env we env file, we import the values, and those values are loaded into the config parameter or the variable. And then we again open access to the local open operating system, and we set where the logs are generated and where the tool calling log path is. So in addition to the code being I mean the log generated from the LLM calls, any tool specific logs are also stored separately for us to refer at a later point in time. Then we have we import get chat LLM from LLM utils models. And in this particular part, again, we this is using replicate, but if you want to use a different like Olama or Watson, you can uncomment these and comment this one by using a hash. Then we have a list of transformations which we are doing here. So the basically the DPK tools that we are using here are specified here. In this case, it is Llama index tools. And from that, we are using the DPK transform tool specification. So the DPK transform tool specification is stored in DPK spec, and from there the two tool list is created and stored in the tools. So whatever the tools that are available in the DPK specification are stored in tools, and the list of it is printed for you to refer to. And once the DPK tools are available, so we go find the tool that is in the list, and for each tool that is there, we return the tool. And if a tool is not found in the code base, it raises an error. If the DPK LangChain tools are not there, it tries to import from function tools from Llama index. So this is the LangChain implementation of it, while this is the Llama index implementation of it. This is a basic way error handling. If you see, it is doing it very simply. I mean, it is using, if this is defined, if this value is present, it directly goes in here. If it is not there, what we set it as true or false at the top, if you remember. If it is not there, it goes to the Llama index part of it. It is similar to it, but instead of importing tool, it is called as function tool in Llama index, and the rest of it is similar. So it is getting typecasted to function tool, and here it is typecasting it to tool, and that is getting written back and stored in the tool specific. The second cell now talks about the text description of it. So it is getting the description of the tools and storing it along with the name. Again, this is the LangChain implementation of it, and this is the Llama index implementation of it. So earlier we had different prompts, right? I mean, we had a planner prompt, we had a judge prompt, and we had a code generator prompt. But in this case, we have a single prompt that is defined here. So the tools that are there are being mentioned here. I mean, it is basically asking the following questions and asking the LLM to answer it as best as it can. And you have to access to the following tools, and the list of tools that are listed here is mentioned here. So the first thing is question. I mean, the input question you must answer. Then the thought, how should you think what to do? You should always think. And action, what is the action to be take? It generally is one of the tools that are listed here. And the action input is the input that is supposed to be given to this tool, and observation is a result of what after the input and the action is taken care on the input by the tool. And after that, this thought or action input or observation can repeat 10 times. So this, from this to this, will keep on repeating. So thought, action input or observation will keep on repeating till it determines that it knows the answer. So we are not specifying how many times it needs to iterate, but it will infer that directly from the data or the knowledge it has access to, and it will give the final answer in to the original input question, which is this one. So the final answer or action should appear in the answer, but not in both. I mean, it should not have either this. It should appear either in action or final answer, but not in both. Okay. Follow the exact action input format provided in the examples when crafting your response. Avoid numbering the output. So I mean, unless we specify what happens is LLM at every time, it will come up with its own format. Sometimes it will be numbers, sometimes it will be hyphen, sometimes it will be tabs, sometimes it will be alphabets. So we want to ensure that there is no such thing. we don't want to add one more layer to do the output transformation or the post processing of the output. So sometimes what happens is, if the inputs are coming from multiple places, you might want to have a pre-processor where the inputs are harmonized in the same format before it is fed into the LLM. And there is an example which is given. So what is the task, which is dedupe, and what is the input that is given, which is the doc ID, and the output is the deduplicated set of the documents in the transform order. So that is how it should be. I mean, the output should be the following. The thought is mentioned here. It has to execute dedupe and doc ID one after the other. So this is how it is doing it. So after that is done, there is another example also given. If it was using local array cluster, how it needs to be done, because this is a simple implementation on your laptop. This is something specific to it. If you you're not using it, you can remove this part as well. But since it was catering to both the formats, it is given here. So if you want to save on tokens from both cost perspective and time it takes to process it, you can remove it. Okay. So now we are invoking the agent to create the plan. So the plan is now created by itself. So it has the prompt template, which is it is importing from langchain.prompts, and in that prompt template, it is trying to create an agent. So the agent by default it is specified as a null thing, and once it is specified, we are then invoking the agent where the input, the tool names, and the tools are specified, and the output of the agent is specified as saved here. Once the agent prompt is created, we pass the plan, we iterate through it, we list all the information that is there, and all the steps are printed out. And if there are any characters which are not required, which need to be passed out, we use regex by importing the regex import.re and remove all those information that is not required. Okay. Then if we are passing the JSON inputs, we import the JSON, and we then load that as the input to the dictionary and make the call. So we are then executing the transforms function by calling their tool definition. So all this information is first found. I mean, if the match is found, that is used as a tool name, and then the tool name is sent to the list of tools to find the exact tool. And again, it keeps repeating. I mean, if not the first one, if the next one, and all that. So all that is now going into the tool input as a dictionary input. And then we are running the tool with the input parameters. And if it is defined as a LangChain, this part of the code gets executed. If not, the llama index part is getting executed. If none of these are there, I mean, then we have the output of it, if it is not Parquet files, it is stored in this particular folder. If it is in Parquet files, it is stored in a different folder. The contain Parquet files ensures that the information is stored separately, whether it's a Parquet or not a Parquet folder. And we also measure time in terms of how long it is taken to run this. And we also have a bit of time in between, so that you won't hit any rate limits when making the LLM calls. And finally, you can inspect the generated output file. All those things are in the form of Parquet. Then it reads the Parquet files as a data frame, and all that file, each file in the Parquet is loaded into the data frame. And from that, it is converted into a pandas data frame, into a single data frame to concatenate it, and that is written. That would be called here. I mean, that is how it is. The output of that is given, and along the top two records are printed out for you to go through. So this is at a high level what is there. We'll go through the DPK requirements text, which will contain the additional set of variables or the data prep libraries that we need. So it contains the data prep toolkit version 0.2.3, data prep toolkit transforms, all and ray version 1.0.0a2, and the deep search toolkit. So we also have a set of additional helper functions as well to parse the output. Again, this is using regex pattern matching to ensure we go to the output folder and take care of it. So apart from these examples, if you want some basic examples, you also have notebooks that are available to take you through that information. I mean, this was the first collab transformation. If you want to do it, if you did not have access, this is a very basic one. Then you have RAG for reading HTML and PDF. You have PDF processing. You have fine tuning of LLM. You have PII redaction. You have input test data generation. You have a lot of other utilities as well, like file utilities, any actions that need to be done on files. So if you see that read Parquet files as data frame is actually defined here. So all this is coming out of, I mean, that is why it is called an accelerator. If you had to think of all this in the form of an architectural diagram and design it and then implement it, it would take a lot of time. But what you have here is you are leveraging what is already available and you are applying it for your specific use case by coming up with your own specific business context or knowledge to resolve that particular scope. And I mean, all the transforms are available here. Like we have talked about, we have code transformations, language transformations. Universal transformations are common between code and language. We have image specific, and we have LangChain or how to use memory, and all that is available here. Then we have tools. So how to ingest from Parquet, that information is available here. So all the source data is available here, ingest to Parquet if it is local, or if you are ingesting from S3. Even IBM, this S3 is basically an Amazon simple storage service bucket. The IBM blob storage cloud object store is also a variant of S3. So the same code works there. If you are ingesting from local, you can use this. And I think this might be calling either of these two files. Let me minimize ingest to Parquet. Like in chain, we have the DPK transformation chain. So if you want to go through that code, that is also available here. Then we have code specific transformations like code to Parquet, code profiler, code quality. So these were used in the DPK, the first use case which we have gone through. So code to Parquet, code profiler, code quality, and all. Then we have language specific things which we have used in the second use case, which is basically doc chunking. doc quality, uh, docking to Parquet. Enrichment, we have not done it, but you can see how you can enrich a particular piece of language using the enrichment. Then we have extreme tokenizer. Then we have Genesis, Ignisys web classification. We have HTML to Parquet. Then we have language identifier. If information is coming from multiple languages, it will first do the language identification and then do it. Then we have PII redactor, readability, similarity to ensure we are deduplicating it, and the text encoder. And universal is common to both code and uh, language. We have a list of block lists. So anything you want to block, which should not go to the users, uh, if it is extreme content, you would want to add it to the block list. Then you have Bloom, C4 annotator, collapsing, doc ID generator, deduplicate function. You have filtering. You have search. You have resize, tokenization, and web to Parquet. Any questions, anyone, or should I go through this transform chain which was used in the DPK, which we were talking about a little earlier? We can go through that as well. Are there any questions in the chat box, Sai or Milan? If not, we can probably ask.
Um, Sir, I have opened the chat for the students, so they can now ask questions. If they want, students, the chat is open. You can drop your questions here. Students, can you try sending questions? Okay.
I mean, in the second use case, I'll just till the questions keep coming. I don't want to keep them. So we have primarily PDF to Parquet, which converts the PDF files to Parquet format. Then we have exact dedupe, which removes exact duplicate documents based on the document hash. Then we check for quality. It checks doc quality, checks for inappropriate content using a list of bad words. And filter removes the documents that contain the inappropriate content. So once the plan is approved, the agent generates a Python script that implements the pipeline. The script will include importing all necessary Python modules, a function to extract output folders from transform results. The main execution workflow runs against each transform in sequence, and the command line argument handling with configurable parameters. The configurable parameters are basically the input folder, which defines the input data folder, out folder, which is the folder where the output data will be stored, and the doc quality bad word file path is the path to the list of bad words, which is used by the document quality transformation function. And we can basically customize the DPK planning agent for any specific use cases. You can change the natural language description to describe different data processing requirements. We can specify additional constraints in the constraints.python file. I think we haven't covered constraints.python file. I'll go through that now. You can add examples, provide example plans in your examples.python file to guide the plan towards similar solutions, and add new transforms in tools.python file. So I'll go through those two now. So constraints, right? So the constraints that are defined here, initially it is not containing any constraint. Then the constraint is added, where the existing constraint is added with a new constraint. If the dedupe, exact dedupe tool is needed, then it must run as the first step or immediately after the PDF to Parquet. And the next constraint is, if the tokenization transform is needed, then it must be run as the last transformation of the plan. Otherwise, it should not be part of the plan. And then the PDF to Parquet tool is run as the first step if the input is PDF files. So there is a different set of constraints which are given for fuzzy dedupe. Since we were not using fuzzy dedupe, these were commented out, but if required, we have to then include it. I mean, if you saw the diagram initially, it had both exact dedupe and fuzzy dedupe, both are there. So you can experiment once by uncommenting these constraints and see how the results are coming. Then you can add your examples in examples.python. So it is giving a couple of examples for a generic task and how it has to do it. Okay. And then we have the tools.python, which talks about where each of the tool is mentioned along with its description. So the tool name is exact dedupe. The input is specified in the input folder. Output is specified in the output folder, and where it is stored so that it can be imported from. The same goes for PDF to Parquet, doc quality, doc identifier, language identifier, filter transformer. Then we have tokenization, and probably one more after this. Yeah, whatever not implemented, it just says suitable tool cannot be found. And if you want to use in constraints the fuzzy dedupe, you have to come and uncomment that here as well. Okay. We also have prompts for agent helpers. So how to create that, how to define the planner node, how to check if the plan is complete, how to generate the run. This is for the first use case, how to define the judge, all that information. And after that, if to check if the plan is okay, if judgment is required, if the user review is okay or not. So all that we had gone through is also coming through in the form of prompts, and get user state review and the extract the Python code from the information. So when it gets generated, it gets a code block which is defined by Python and ending it here. So from within it, it is generating the code block. Then we have callback functions. We have logging functions. So if you have not done any kind of debugging or logging, or printf might be the common way you might have done that. But in a enterprise context, we generally write it to log files so that they can be accessed in the background and keep track of long running processes. It's in such a way that you just don't stop it, but it keeps on running and running. And models contain what are all the models that we are getting access to. So we have the replicate chat model, we'll have the IBM Watson X model. Then we'll have the Olama model. Okay. And to visualize the plan, again, we used Mermaid. If not, you can, the exact visualization of the plan is also written here so that it can be used to visualize the plan. I mean, any questions? Somebody can call out the question, or should I go through the chat?
Students, if you have any more questions, do drop here in the chat box. If you are not able to understand certain portions, we will always reshare. We will be sharing the session recording. Do not worry. For now, if you have any questions, do drop here. Sir, can you see the questions?
Okay, let me go to the chat in that case.
Yes, I think.
Which one should be addressing now?
Sir, sir, can you see the questions coming like uh, how our logging different from accept? So please run the examples. And sir, is it a blueprint of the AI agent program? Uh, sir, please explain in Hindi. Sir, are you able to see these questions?
Yeah, I'm able to see it, but I might not be able to explain in Hindi. My apologies for the same. But see, the GitHub, 1 minute, let me switch to that. I have to minimize the chat. So if you come here, if you go to you are able to see the main thing, right? What instructions that you have to follow, the installation guidelines. Hope you are able to see it, right, Tanmita?
Uh, Sir, did you drop any message?
No, no. What I'm sharing.
Yes, sir, it is visible.
Yeah. So these are the step of Git commands that you need to use. So you will be starting with the Git clone. Then you would be switching your after the clone is done to the examples agentic directory. Then you will be setting up the Python virtual environment and installing the dependencies. First, you will be upgrading pip. Then you will be installing Jupyter, IPython, and IPyKernel. And then you will be installing pip requirements for the first use case. For the second use case, additionally, you have to install the requirements which are there in the DPK requirements. When we go to the second use case, it will install both this and the next one. Okay. If you have access to the LLM, any of this, either replicate or Watson, you can provide the keys in the env file, either for replicate or for Watson in this particular format. If you are using if you download your own Olama model, IBM has tested it with Llama 3.3. If you are using a different version, you might want to specify a different name at the end. So from that perspective, the code is ready for you to run. And we also, I think the other question which was talking about is from the logging perspective. So logs are maintained using the logging file. So all the information is stored in the logging handlers. So it is, instead of errors, I mean, there would be multiple levels of logging, like debug level, where the most information is available. info is generally what is getting processed and all. Warnings are there are some issues, but it is still able to process. So that will be coming in the case of warning. Then in the case of errors, it will be uh, showing what is the error. If you see any error, generally when you are trying to execute and something fails because the dependency is not there, or the file or input or output folders are not there, they'll come under errors. And critical is basically which is very critical OS level issues, like access is getting blocked and everything. Those are mentioned at this level. So there are 1, 2, 3, 4, and 5 levels of logging that you can specify. We have gone through this at the start of the course as well. And you also specify what logs are written at which level. So once you do it, you can take it forward and go through that logs to identify what is the issue that is there. If you are able to correct it yourself, that is well and good. If not, you go to Discord. We have gone through and showcased where you can raise your issues in Discord. Let me go to the start again. So if you come here, yeah. So the data prep kit Discord channel, this contains all the issues which are commonly frequently posted, and you have to agree to a terms and policy conditions. I cannot do it right away. Since this is my official computer, but you would be able to access all the information that is there. Okay, let me do it. I'll undo it later. So you will see what are all the issues that are available. So this particular channel is specific to Discord for data prep. Let me run it again. It is not giving me access, but you can, we just need to sign up and be able to access this particular information. So DPK, I mean, you can also go through the awesome LLM under LLM data section on GitHub. You can also access DPK via IBM SkillsBuild download and add to the application hub of AI sustainability catalog. So you can access this DPK from multiple ways. You also have a developer blog where you can see how various other developers have been using it. We have, I mean, let me open these. So this was what I said. It takes it's a bit lengthy in scope. So what it gives here is specific to how we are doing the fine web data set. That is the starting point, and came up with the Genesis web data set and how many iterations we have gone through. So we started off with fine web, and we have generated a fine web version 2 as well, which is a subset of it, and we have a baseline version of it as well, refined web. So what are the steps that were taken and what are the benchmarks that were created to take it forward? All that information is made available here. If you see, I mean, Genesis Web is in between FineWeb and FineWeb 2. It was created from FineWeb, but you can also probably take it from Fine Web 2 as well, but it still has a higher uh, evaluation score. So from that perspective, that is what is the quality of the model is specified here. And then we have the developer blog, how to start off with the data prep toolkit, and what are the next steps that are there, and how much time it takes for you to complete the data prep toolkit. Okay. I mean, how to use it? You have some of these unstructured data meetup recordings available on YouTube, where the information is stored in Milvus is also, and what are the process data sets, what can be done. All that information is available for you to explore more further. So we have done the very basic version of it, and you can bring your own transformation to take it forward as well. You can even integrate it with Milvus. And this is the steps which we were talking about. So when we integrate it with Milvus, after creating the vectors, we store it in the vector database and use those for vector searching. So when you do a RAG implementation of it, the query comes, the query gets vectorized and searched against this vector DB, and the response is retrieved and sent back. So you can keep adding modules to whatever is created. So all that information is made available here for you to take it forward. Then we have how to unleash the potential of LLMs. What is the deduplication chunking? How to remove hate, abuse, and profanity, the HAP filters, and how to do PII reduction. All these information is available, so that we can directly take it and use for agentic application as we are showcasing now. Okay. And there's a LinkedIn article also. So how to use that information? You can go through this same, how to use Conda to access it, or use to access it. There are different ways you can go through it. All that information is available here in multiple paths and channels. So, and how to increase the data quality by developing a data cleansing tool. This information is also made available to you. Then I mean, instead of basically print is very localized. I mean, if you run the print again, output will not be stored. Logging is a way where you store it locally, so that it will have a timestamp of when a particular uh, version of a particular code is being used, and what was the response that is there. So logging helps you in multiple levels. You can go to the most detailed, or you can only log whatever is required from you. LLM is not free. Some of them might come with free for a certain stages. If you have access to your own API keys, you can use that API key, but in conjunction with the endpoint for that API key. You should also know that. And the code has to be changed to ensure the format in which you are sending the input and output is acceptable to that LLM. So you can use a Gemini key if you have it. Whoever is getting a Windows error, you have to go through the Windows steps. Let me go back here 1 minute. So if I go back, if you see on the top here, there's a link, the data prep toolkit, and it talks about uh, Windows users. So you have to click here for running the transformations on Windows, uh, how to install specifically, and all that information is made available here. So you have to use this specific set of tools for taking you forward. Uh, Yeah, Olama is free, and yes, you can use it locally. Anything else that is there?
Sir, one
Yeah.
question was there that students were asking you to execute it while explaining. Is it possible, sir, now to like explain it?
Uh, Not now. They'll have to execute it on their end. I I'm not able to execute it in this particular laptop because it is a client one.
Okay.
We will have to take it up at their end.
Okay, sir. Okay, sir. Also, sir, students were asking if the links can be shared. So can you share the links they are mentioning about any links that they
Yeah,
can
there
use?
is only one link that needs to be used. 1 minute.
Okay.
So this is the same link which was given. I mean, so this is the link from which you can go to Data Prep Kit,
Hmm.
and from within Data Prep Kit, go to Examples and Agentic. So within Agentic, we have covered both the DPK planning agent, which is a code generation, and DPK as tools, which is the natural language based AI agents. So both these are creating multiple agents. In this case, we had a planner agent, a judge, code generator, and code validator. Here, depending on PDF to Parquet, we have different tools which were automatically generated from the code to run the data transformation. Then doing the document generator, then the deduplication, exact deduplication and fuzzy deduplication, and then creating the embeddings using the LLM and storing it. If you do not have access to LLM, you can just stop at that stage and see. It all depends on what you want to do. You want to extend the use case further, you can have your local instance of Pioneerless and then take it forward as well. So from that perspective, the amount of transformations that you want to create your own transformations, we have also covered that as well. How to create your own transformation, a custom transformation, and how to add it as a tool as well. We have mentioned that. Let me go back and showcase. So we have the custom transformation, how to add your own custom transformation as well. So we have gone through this as well. And once we are doing execution, if you want to scale it up from a laptop to a cluster, you can do that as well. And you have Kubernetes. We are not going to cover Kubernetes and others here, because we'll be using deployment using relay.app in on Monday's session. You can share that link if it was already not shared. I thought we have already shared the link earlier.
Yes, there the first link that you have shared with us, we have shared that link in the
Yeah,
WhatsApp groups and the chat box as well, sir.
yeah. So all the subsequent are basically within it. I mean, it would be too many to share each and every link, because everything is in the same repo. They can go through it at their own convenience.
Okay, students, any more questions? So anything related to the learning plan and WhatsApp groups, we stay till the end. We will notify you everything. But now, ask sir any questions if you have. Sir, I don't think they have any questions. I am not seeing any questions. Okay, sir, there's one question. How can run the code inside terminal? Sir.
You have to clone the information. Again, I'll repeat it. So if you come, let me minimize this. Yeah, okay. So if we are here, this is the start. Go to examples. Uh, then you have the agentic part of it. And this contains the steps which you have to run in your terminal. You have to first create a Git clone, then create the Python virtual environment, install the libraries and the requirements, and this would be sufficient for the first use case. For the second use case, additionally, you have to install the DPK requirements as well. So that will come as an additional step here. So all that information is also available in the respective thing. So the first use case is DPK planning agent, which contains the same set of steps. Like it will start with the install requirements. If you go to the DPK as tools, the second use case, it will showcase that you, in addition to installing requirements, you are also installing the DPK requirements. And then you are taking forward. And you also additionally install Llama index, because that is the default implementation that we are using here. Okay.
Sir, I think a few students, I'm finding a very common question among them is
Mhm.
that what are they actually, like they're asking what are we actually building here? So I think there might be a confusion. So can you clarify that?
Yeah. So what we are building is, so if you are taking the second use case, you are taking a set of PDFs and doing the deduplication. So you are converting from PDF to Parquet, in extracting the text from within the PDF. Then you are uh, chunking them and creating a document ID. And for those documents, we are doing a deduplication. So these are the steps which we are doing. We are not doing fuzzy dedupe. It is commented out, but if you want, you can uncomment it and do the fuzzy dedupe. And then when you make LLM call, you create the vector equivalent of the information that is there. So all this is done through the agent. I mean, you are not writing any bit of code for doing any of this, but you are giving it instructions saying that this is the steps that I need to do, and the code is generated automatically on your behalf. So it can be anybody. If I'm a mechanical person and I have some set of documents that I need to understand or to refer to, I can run this and create a library of all those requirements or specifications that are coming in, and be accessible to me when I want to pose a query to it. So when you pose a query, you have a RAG pipeline. I mean, so in addition to agentic, you also have a RAG pipeline as well. So you can use that to retrieve what information is stored from this. When the user poses a query, you can go there. So the same way, if you go to the first use case, which is DPK planning agent, in this case, it is generating the code for doing the data preparation activities. So it is we are giving information in the form of prompts, and it is generating the code for doing the input transformations from one step to the other. And that code is being evaluated internally by the judge, and additionally, if required, by the user. If the user step is not required, it directly goes, and if it determines the code is of good quality, it generates the code, and it can even validate the code. So all those are possible. So this is the benefit of having the agent. I mean, you talk to it in the natural language, and it generates the code to do the activities on your behalf. So if you're anyone in your network, your family members, relatives or friends have any particular business use case, you can define various agents to you can divide that problem into multiple subsets, and each one would be done by a different agent with a task goal which is specified for that particular task, where you define what is the input that is being given and what is the output which you are expecting, and you validate these two to ensure the processing is done correctly.
Students, do have still any questions regarding the masterclass? If there is any questions regarding the learning plan and WhatsApp groups and the certifications, we can have once the session is done. So encourage students if you have any doubts regarding the masterclass. So students, if you're finding difficult in the concept, you can revisit the recording that we'll be sharing end of the day. Yeah, assignments, everything will be posted in the groups. Yes, sir, I think we are good to go as there are no questions regarding.
Thank you, Tanmita, Sai, and Milan.
Yeah, so I would. So, Tanmita or team, you can close the chat box for now. So, thank you, Mr. Shashank, for this insightful session. Students, I'm sure that they have got a clear understanding about the industry grade AI tools and the practices. We truly appreciate your time and expertise and looking forward for your more sessions in our further BBLs.
Thank you, Sai.
Yeah, yeah. So you can drop off. We will clear those. We will clear some doubts if they
Okay.
have anything regarding the certifications and all. Thank you so much, sir.
Thank you.
Yeah. Students, so the attendance sheet will be shared now. So it is very important to mark your attendance, so that it will be also taken into the consideration that whether you have attended the master class or not. And if you still have any doubts uh, regarding any like a doubt in any process, like how to get your certifications, you can also reach fill the Google form for queries. So first, before that, I request everyone to please don't leave the session without filling the attendance sheet. Yeah, if your friends who left the call already, please ask them to fill the attendance sheet. Yeah. So if you really have any problem regarding the program, how to complete your learning plan and how to get your certifications, if you stuck at any moment of getting your certifications, you can feel free to fill the query form. So and I hope everyone have started their learning plans. Yeah, I have I'm sure that everyone have started the learning plans. Yes, no, the chat box is open for you for a minute. Yes, good, good, good. So yeah, I can see so many S here. So very glad to see that. So I request everyone to please start your learning plans because it plays a very important role. 23rd, that means this coming Tuesday will be the deadline. So on 22nd, you'll be sent a Google form to submit your certifications that you have done in the learning plan. If you still have any doubts regarding how to get your certifications, or if you still have any problem submitting your certification, please go through the orientation program once again. So it is uploaded in the Google Drive that we have already shared last day, and we'll be sharing it today also. And if you find any difficulty of in today's session, so there will be the recorded class uploaded in the same link, so that will be also shared. So I can see so many students they're leaving the call before the call ends. So I make sure that your friends, if there are any of your friends who left the call, ask them to fill the Google form and ask them to complete their learning plans also. Yeah. If there are any questions, I'm opening the chat. You can ask me any questions. If attendance form it's already shared, I'll ask my team again to share it. So we'll be sharing it on your WhatsApp also. The people who are joining from YouTube live, so you can find the attendance sheet in your WhatsApp group also. I think yeah, just now I have shared attendance link in your WhatsApp, so you can also refer that link for your attendance. And I request my team to send the link in the chat box again. Yeah, the link is shared. Yeah, the link is shared in the WhatsApp group also, as well as in the chat box. If you have completed the learning plan, so please make sure that you're downloading your certificates as well as your badges from Credly. Yeah, we will be sending you the link on 22nd so that you can upload by 23rd evening. Yeah. And the assignments, I can see so many questions on assignments. Like assignments will be sent in your WhatsApp groups again. And I can see learning plan is compulsory and question mark. Yes, it is compulsory. Without completing your learning plan, you can't, you will be ineligible for getting your final certifications. For how to complete the learning plan, you please refer to the orientation session that it is already uploaded in the drive. The link is already shared on WhatsApp. So we'll be sharing it again today. So you can please refer that video. And for the Credly also, we have uploaded the it's there in the orientation video. If you're not there in WhatsApp, 1 second, I'll just send a link here, so you can be part of WhatsApp group also. So people who are not there in WhatsApp groups, you can join this WhatsApp group. Yeah, this is a WhatsApp group that you can join. The assignments, everything will be as like sent on the WhatsApp itself. So yeah, Tanmita, I think like I'm good to go. If you have anything to add, you can.
Yeah, Sai. So I have shared the what's latest WhatsApp group link. Students, I'm sharing it again. Also, I have seen certain questions about the certificate. Okay, so every activity that you will find in the learning plan has its own certificates, but you need to complete the whole learning plan and uh, submit the final certification. Okay, so it's nothing like if you complete one particular activity under section 1 or under section 2, you will get each like certificates for completing each activity, that is for sure, but you need to complete the whole learning plan and submit the final certification. And to understand it better, you need to go through the orientation as your sir has already mentioned. Okay, and about the assignment also, I have seen certain questions like what is the assignment. We have not notified anything about the assignment to you all. We will notify in through the WhatsApp groups. We haven't selected any we are yet to select an assignment for you. For now, we want you to concentrate on the master classes, complete your learning plan, so that once you are done completing the learning plan, you are free to work on your assignment. Okay, so that's the reason we haven't shared the learning plan yet, like assignment yet with you. So yeah, that's all I could say. So, Dia Dubey, you have searched in actions, okay, but make sure you see that all sections that are complete. You have completed all the activities that has been asked to complete. Okay, so once it shows 100%, you just again for your simple for your easy understanding, I'm saying this. If you see that you have completed your 100%, like learning plan is 100% completed, you can clear the browser, you can re-enter the learning plan by clicking on the learning plan link. So once you enter that, you will see the first page having the option actions there. If you click on that, you will see this option view completion certificate. You can click on that and you will get the final certification to download. Okay. So this is the easy part I'm saying you. If you are finding it difficult to like come back and search for the certificate, you can simply close the browser, like clear the browser, then go again, click the activity, click the link of the learning activity, and you can find the final completion certificate. Okay. Okay, okay, sure, sure. I hope your questions are clear, but yes, it is time we wrap the session. And for any questions regarding your learning plan or platform, anything, WhatsApp link has been shared in the group, Nagarani. So please do check it out. Uh, Also, I'm taking this was okay. So yeah, I think your questions are quite clear now. See, I have already explained, Anshumana, that how to get the final certification. You can again rewatch this whole session to understand what I have instructed. Also, go through the orientation as well. Okay, you will understand how to get your final certification. And anything related to any platform related, learning plan related questions, you can use the query form to reach out to us. Thank you so much,
Yeah.
guys, for being consistent. Yes, definitely. We are starting to like reply the query form. We are getting questions and queries. Yes. So yes, you can reach out to us. Okay, fill the attendance form now. For today, do not forget to fill the attendance form today, Ridhi. It's fine. If you are being consistent, if you are completing the learning plan, that will mark your attendance. But make sure that you have attended today's session. You are filling up the attendance form. Okay. Thank you so much, guys. Sai, if we are done, then we can wrap up the session.
Yes, if you have any doubt regarding how to get your certification, how to complete your learning plans, please go through the orientation video that we'll be sharing the Google Drive link today itself. So I encourage you guys to go there and sort all your doubts, because on 23rd you have to submit your learning plan. Yeah, yeah, I think we're good to go, Tanvita.
Okay. Okay. Thank you so much, guys, for joining, for being consistent. Hope to see you all in the Masterclass 3. For now, take care. Enjoy your weekend. Bye. You can drop the meeting now. You can leave the meeting.